Okay, so in this video we're focusing on writing equations of lines. So if we're given the slope and the y-intercept, you got to think about what format would be the best to use when I'm writing the equation of a straight line. Well, slope and y-intercept, I mean, it's pretty obvious. We need to use slope-intercept form. And that's just simply y equals mx plus b. If we're given just 2 points, well, we can still do slope-intercept form, but first we're going to have to find the slope, okay? So how do we calculate the slope? We use the slope formula. y2 minus y1 on top of x2 minus x1. That's all it is. Once we know the slope, we can then go back and use either one of these 2 points and find the y-intercept. And then once we have both the slope and the y-intercept, we can use y equals mx plus b. So far we talked about the slope-intercept form and the standard form. And we want to know what was the name of that third format that you learned in Algebra 1 that we haven't really discussed so far. Well, that's called standard form. Or sorry, not standard form, but point slope form. Excuse me, point slope form. Okay, and that's just simply y minus y1 is equal to m times x minus x1. Okay, so here I need exactly 1 point and I need the slope. So I'm going to have my x1, y1, plug it in. I'm going to have my slope, plug that in. Now, there's a problem with this. There's infinite number of points on the line. So really, if I chose, let's say 0, 0 sits on the line, I choose that point, then I'm going to get a certain equation. If 1, 1 also sits on that line and you plug it in, you're going to get a different equation. Yeah, the graphs of both of those equations will be the same, but the equations themselves will not be unique. So to be unique needs to be the one and only. Okay, so that's a problem. If we can't have tons of different equations all representing the same graph. In mathematics, we're always looking for the unique solution, the one and only solution. So that's why this particular format, point slope form, presents a problem for us. So instead, what we're going to do is, yeah, we can start with this, we can start with point slope form, but we're always going to turn it into slope-intercept or standard form. And I'll leave that up to you to choose whatever you prefer, whatever you like. A lot of people like slope-intercept form because it's easy. It's got y equals. You can put that in your calculator. I personally like standard form the best. It's just whatever you want to do. All right, so here we want to be able to write an equation for this line. Okay, now we have 2 formats we're going to use, slope-intercept or standard form, whatever you want to do. I'm personally going to do slope-intercept because I think it's a little bit easier for this type of situation. Because I'm given the y-intercept right here at -1. The y-intercept, of course, is just where it crosses the y-axis, so I know b is equal to -1. And I can just easily use the graph to find the graph at whatever point to find the slope. So I'm going to pick a nice point on the graph, maybe this one right here. This point is 2, 2. Okay, but I know my slope is just simply the change in y over the change in x. So I want to look at how much to get from this point to this point. What do I do? Well, I go up 2 units, so that's a +2, and I go to the right 2 units, so that's +2. So my slope is just going to be 2 over 2, which is 1. So the slope for this line is 1. So again, like I said, I want to use slope-intercept form. So that's just y equals mx plus b. Now I'm going to plug in what I know, so I get my equation of the line. I know my m is +1, I know my y-intercept is -1, so y equals 1x minus 1. Let's simplify a little bit. So y is equal to x minus 1. Okay, and that's it for that equation. I mean, so this equation is unique. It's the one and only equation of its form, its slope-intercept form, and it'll produce this graph. Okay. Write an equation of the line that passes through this point and has this given slope. So here we have exactly 1 point and a given slope. So we're going to start off with point slope form But since that's not a unique solution, we're going to transform it into slope-intercept form, okay? Or standard form, whatever you prefer. I'm going to do slope-intercept. On the next example, I'll do standard form. Okay, so this is going to be my x1, y1. This is obviously my m. And then, so we're starting with point-slope form. So that's just simply y minus y1 is equal to m times x minus x1. Plug in what you know. So now, be cautious. You do need these parentheses, so don't forget that, okay? So plug in what you know. So we have y minus 3 is equal to negative 1/2 times x minus 2. Well, that's the equation in point-slope form, but like we've already discussed, that equation is not unique. It depends on what the point we have on that line, what point is given to us. So if we were given a different point, this equation would be different. We want a unique solution, so we're going to try to get it in slope-intercept form. To do that, we need to get y by itself. So we're going to go into y slope-intercept form. So that is y equals mx plus b. So that's how I want my final answer to look. So to do that, I first need to get y by itself. I'm going to add 3 to both sides. So I have, starting off, y equals negative 1/2 x minus 2 plus 3. Okay, it doesn't quite look like this yet. It's getting close, so I still need to simplify, so I'm going to take care of my distributive property. Okay, so I have y equals negative 1/2 x plus 1, and then this plus 3 just falls down. Simplify one last time. So y equals negative 1/2 x plus 4. So that's it. That's my equation of y-intercept. So here it's very clear to see that my slope is negative 1/2, and my y-intercept is positive 4. And that's it. Okay, so again, we could have turned this into standard form if we wanted to. I just picked slope-intercept form. I'm going to leave that choice up to you. But this is a unique solution. This is the one and only slope-intercept form for this line. Okay, we have the same type of problem. We have a point, but now we want it perpendicular to this line, to this given line. So we have to remember that perpendicular, anytime we see perpendicular, we need to start thinking opposite reciprocal. And just remember, opposite in this instance means change the sign, and reciprocal means flip the fraction. So first I need to recognize what is my given slope. So my given slope is negative 3. Well, then that implies that my perpendicular slope, which I'm going to call MP, my perpendicular slope is equal to positive 1/3. So that's the slope I'm going to be using throughout the remainder of the problem. So I'm going to cancel this out. I'm going to cross that out. I don't need it anymore. I'm done with this line. I'm going to cross it out. I'm just crossing out those pieces of information because I'm done with them. I used them all that I can. I don't want to get confused by them, so get rid of it. Okay, and now I want this line to have this slope and to go through this point. So x1, y1. So I have a point and I have a slope. So I need to start off in point slope form again. So point slope form again. So y minus y1 is equal to m times x minus x1. All right, well now we just simply plug in what we know. So y minus 2 is equal to 1/3 times x minus 3. Okay, well we want a unique solution, so this time I'm going to transform this into standard form. Because I want a unique solution, so I want it to be in standard form. Now, if you prefer slope-intercept form, that's okay, but you just need to be aware of how to do both forms. So remember, standard form ax plus by equals c. Okay, that's what we're trying to get our final answer to look like. So first things first, I need to get my constants on the right-hand side and my variables, both x and y, on the left. So to do that, I'm first going to take care of the distributive property. So I have y minus 2 is equal to 1/3 x minus 1. Okay, I need to get my constants on the right, so to do that I'm going to add 2 to both sides. So I have y equals 1/3 x plus 1. Now I need to get my variables on the left. So I'm going to subtract 1/3 x from both sides. So I have negative 1/3 x plus y is equal to positive 1. Well, you might have recognized right here, this is in slope-intercept form, so if you really just want a slope-intercept form, there you go. But I want standard form. Now, it's really close. We have some restrictions on slope-intercept form. We know a and b cannot both be 0, and certain textbooks will tell you that a should also be positive. Okay? So we want a to be positive. Well, we have a negative a. Well, to maintain the balance, remember what we do on one side of the equation, we have to do on the other side. So to get rid of this negative a, we're going to multiply both sides of the equation by negative 1. All right, so on the left, I'm going to have negative, negative makes a positive, so 1/3 x minus y is equal to, on the right, positive times negative is negative, negative 1. So this is in standard form, and that is a unique solution. Moreover, I know that a is equal to 1/3, b is equal to negative 1, and then c is also equal to negative 1. And I can actually use a and b to find the slope, so there's a little trick to find the slope. So m is equal to negative a over b. Well, in this case, all it is we have, all right, negative 1/3 divided by b, negative 1. Well, negative, negative cancels out, gives a positive, so we have 1/3 divided by 1. Well, think about it. Anything divided by 1 is itself, so our slope is 1/3. Well, if we go back up to where we had slope-intercept form, we had 1/3 for our slope. We go back up to the top, what we found for the perpendicular slope, 1/3. So that's how you can use standard form to quickly find the slope of a line. So again, this line is, this solution, this equation is unique. That's called the standard form for this particular line. Okay? Another type of problem, very similar. This time we want the parallel line to this given line. We have one point, and it has to go through that one particular point. So we need to start off with what parallel means. Well, anytime we see parallel, we know the slopes are the same. So the slopes are the same. So here I just need to identify what's my given slope. So my given slope is negative 3. Well, that means my parallel slope, which I'm going to call MP, is also negative 3. So that's the slope I want to use for this line. I want to cancel out this given line because I'm done with it. I'm going to cancel out this because I'm done with it. I'm ready to move on. Now we have a slope and we have a given point. I'm going to call that x1, y1. So now we're going to start again in point slope form, and then you make a choice. Do I want my final answer in standard form? Do I want my final answer in slope-intercept form? I'm going to do slope-intercept form this time. That's just my preference. All right, so I'm starting in point slope form. So that is y minus y1 is equal to m, it's x minus x1. And then we just simply plug in what we know. So we have y minus 2 is equal to negative 3, x minus 3. Okay? Now, I said I want to do slope-intercept form. You can do standard form, whatever you prefer. It doesn't matter. I'll leave that choice to you. So I'm going to go to slope-intercept form. So that's y equals mx plus b. That's how I want my final answer to look when I finish this problem. Okay, so to do that, I first need to get y by itself. So I'm going to do that. My first step is going to be to add 2 to both sides. So I have y equals negative 3, x minus 3 plus 2. Now I need to use the distributive property. So I have y equals negative 3x plus 9 plus 2. and then finally simplify it. So y equals negative 3x plus 11. So this is my equation of my line. It is unique. It's the one and only in slope-intercept form. And I know from this that my slope is negative 3, just like we said it had to be, and my y-intercept is 11. Right? Now, a little bit different type of problem. Here I'm only given 2 points. So first I need to find the slope of the line. Then you can make your choice. Do I want to do slope-intercept? Do I want to use standard form? I'm going to do slope-intercept. Anytime you have 2 points like this, it's honestly probably a little easier to do slope-intercept. Okay, so first I want to find the slope. Okay, this will be my x1, y1, x2, y2. And we know the slope is given by the change in y over the change in x, which just means we're going to take y2 minus y1 all over x2 minus x1. Okay, final minus initial, just like we talked about before. So this slope is given to us, just plug in what we know now. We have 4 minus a negative 1, so really 4 plus 1. And then 3 minus a negative 2, so really 3 plus 2. So taking care of that, we have 5 over 5, which is equal to 1. So my slope is equal to 1. Well, we already said that we want to get our answer for this particular problem. We're going to put our answer in slope-intercept form. That is y equals mx plus b. Okay? Well, so far we only have m. We still have yet to find b, so we need to do that. Well, fortunately what we have is we have 2 choices for x and y. We have x1 and y1, or we could use x2 and y2. I'm going to use x2 and y2, and what I'm going to do is, in my y equals mx plus b, everywhere I see an x, I'm going to plug in a 3. Everywhere I see a y, I'm going to plug in a 4. And then everywhere I see an m, I'm going to plug in my 1. All that's going to remain is my b, and I'm going to solve for b. That's all I'm going to do. So let's do that. So my point was 3, 4. That's my x, and that's my y. And m is up here. So just plugging in what we know now. So we have 4 is equal to 1 times 3 plus b. Now simplify, so 4 is equal to 3 plus b. So b is equal to 1. All right, so now we're ready to put everything together. So my final answer, the equation of my line, is going to be y equals x plus 1. And that's it. Notice here that when I plugged everything back in, I left my y as a variable and I left my x as a variable. I didn't plug in a specific point because I want to represent the entire line, not just one specific line. Okay? Now, we're moving on to another type of line. What does it mean to vary directly? Okay, so vary directly just means we're looking at an equation, a linear equation in this format, y equals kx. And then what's a direct variation equation? Well, here we go. That's exactly what we just talked about. The constant of variation is k, and how do we find k? Well, just get it by itself. So divide by x on both sides, so we have y divided by x. And that's how you find it, the constant of variation. Okay? Now, this equation is always going to be linear, and you might notice, hey, it always is going to have a y-intercept of 0, 0, always. If it doesn't have a y-intercept of 0, 0, then it's not a direct variation equation. Okay, so here the variables x and y vary directly. So when you see that phrase, vary directly, you need to think y equals mx, or sorry, not y equals mx plus b, but y equals kx. What we just talked about, y equals kx. And we're told that y equals 12 when x equals 4. So the very first thing, once we know it's a direct variation problem, we need to find the constant of variation. So we need to find k. So k, we know, is equal to y over x. Well, we know what y is and we know what x is at a particular point, so we just plug that in. So k is equal to 12 over 4, which is 3. So our direct variation equation then is going to be y equals 3x. Okay, so obviously our y-intercept is 0, 0. and I'm going to just use the slope to find my next point. Now this says I should go over 3 units, or I should go up 3 units and over 1 unit. Well, if you notice my scales are in increments of 2. So I'm actually going to double this. I'm going to go up 6 units and over 2. And the reason for that is because we know slope is just the change in y over the change in x, and 6 over 2 is just 3. Okay, so my new point lives right there at 2, 6. And now I'm just going to draw the line. Now we're also asked to find the value of y when x is equal to 5. Well, just plug in. We know x equals 5. So we have y equals 3 times 5. So y is equal to 15. And that's it. Very, very easy. Once you know what direct variation is, it's super easy to use. Okay, now we have a different type of problem using direct variation. It says, tell whether or not this data set shows a direct variation. If so, write the equation relating x and y. So first things first, we need to look at the constant of variation. Anytime you have a problem like this, you want to look at the constant of variation. So k is equal to y over x. And what has to be true is, for every y divided by x, it has to be the same all the way across. So this constant of variation, it has to be the same. That's what it means to be a constant. So I'm just going to use, so in other words, k is equal to y over x, and I have several options to choose from. Y divided by x, y divided by x, y divided by x, y divided by x, y divided by x. So if this is a constant of variation problem, then that ratio will be the same all the way across. In other words, all of these ratios will be the same. And do you need to check all of them? Absolutely, yes you do, because it only takes one to mess it up. If even one of these is not the same ratio, then it's not a direct variation problem. Unfortunately, I know, because I've already worked this problem before, is that this is a direct variation problem. If you go through and check each one of these ratios, you'll get the exact same thing. So let's just double check what that value is. So I'm just going to do the first one, but my calculator has it working. So I take 2 day calculators in a row. All right, here we go. So I have 288 divided by 16, which is 18. So my k is equal to 18. And what you should find for each one of these is it's 18 all the way across. So yes, this is a direct variation problem. So my equation, y equals kx, just plug in what I know. So my equation that relates x and y directly is y equals 18x. Simple as that. So yes, this is a direct variation problem. Tell whether or not the data shows a direct variation. Yes, and we just showed why. Write the equation. We did it right here. Same type of problem. Okay, so the first thing we're going to look at is a ratio, k is equal to y over x. And we're going to check each one of these ratios. So 2250 divided by 0.5, 3430 divided by 0.7, 6400 divided by 1, 1100 divided by 1.5, or sorry, 11,000 that is, 20,400 divided by 2. Okay, and I want to go through and check each one of these. Well, if you find one that messes up early on, you can just stop. It only takes one to mess up, and what you should find is that the ratio is different right here. This one right here that I just crossed out messes it up. So I can stop and just say, no, not a direct variation. Not a direct variation, and it's because this ratio, y over x, y over x equals k, is not constant all the way across. To be a direct variation, that ratio has to be constant. If it's not a direct variation. That's it for writing equations lines. Thank you.